So as you see over here, these double forward slash comments doesn't make this line of code not work. This line of code will be executed, and this text over here will be totally ignored by the compiler. However, this comment over here wraps around this line of code, so this line of code will be ignored by the compiler and will not be executed. Actually, sometimes you can use comments as a useful way to cut out a bunch of codes which you want to test for a minute without. So like if I want to test my program for a minute without this code, this line of code over here, instead of deleting it or something, I could just leave it inside but put 2 forward slashes right before that line, and this line will not be compiled. The next thing I wanted to mention is that, I wanted to clarify about passing variables to functions. I may not have explained that so clearly, so let me clear that up a little bit. Right over here I created 2 functions. This one will return integer and it's called doStuff, and it will take 2 variables. This of course is the declaration of a function, and actually in fancy C++, this thing over here is called the return type, this part over here is called the name, and the rest of it in the parentheses is called the signature, which could include 0 or any amount of variables which will be passed into the function. And as a matter of fact, these variables which are passed into the functions are called parameters or arguments. And here I define a different function, so this is another function header. The return type is integer, the name is doMoreStuff, and the signature has just one argument called variable1, one parameter. And the definition of these 2 functions is right over here at the end. Of course, the real way to do this is to separate it into a different header file and CPP file, but for now we're just going to have it all in the main CPP file. So for now, doStuff will just return the number 6, and that's a valid integer, and doMoreStuff will return 8. Now, how do I call the function? As we learned, we just type the function name and then the opening and closing parentheses with whatever parameters you have to pass into the function. Now, these parameters, these arguments that you pass into a function, can actually be any valid expression you'd like. So if I call doStuff where I have to pass 2 different integer variables, I could either pass in 2 different variables, or I could pass in pure numbers, or any other expression which would evaluate as integer variables. As a matter of fact, because the function doMoreStuff returns integer, it returns a number, so I can pass the result of calling doMoreStuff into the function doStuff. Something like this. There we go, right over here you see I'm calling doStuff and I'm passing 2 expressions. The first one is the results of calling doMoreStuff, and of course because I'm calling doMoreStuff I have to pass in 2 different arguments as well. And then, oops, I'm sorry, doMoreStuff only takes in 1 argument, so let's fix that, don't get confused. And then over here, because I'm calling doStuff, I have to pass in 2 arguments. Here's the second argument. So what happens here is that first of all, the program will jump over to doMoreStuff, bringing in the number 9, and let's see what it's going to do over there. doMoreStuff, bringing in the variable 1, which has 9. This function will do whatever it has to do and then return whatever it has to return. At this point it returns 8. So now that we are returning 8, it's as if I would have typed over here the number 8, because whatever is returned from doMoreStuff is going to be passed into doStuff as the first parameter, as the first argument. And then I put a comma, which means I'm going to pass on to the next argument, which I pass a plain old number called having the number 404. And this can go on and on. I can pass doMoreStuff to the inside of the function doMoreStuff itself, and then I can pass that whole thing also as the second argument of calling the function doStuff. So as you see, whatever evaluates as a expression can be passed into a function as a valid parameter, as a valid argument that has to be passed into the function, provided that it matches the type. If I have to pass in an integer, I must have an expression which evaluates as an integer. I can't use a function over here which returns void or which returns char or some other variable. It can be a function or any expression which returns integer, because that's what I promised that I would pass into such a function. Now, when we declared and later on defined these functions do stuff and do more stuff, we had to constantly remember what are the types of variables that we are passing in. Right over here we had to say it's integer, and this is integer, and over here we're also passing integer. The same thing was in the declaration. We kept on typing what is the type of the variable that we are passing in. However, that's just in the declaration and the definition of a function. When you're actually using the function inside of your code, you don't have to type in what is the type of argument that you're passing in. You could just pass in the variable itself and everything will be fine. So you don't have to type in like int 4 or something like that and then int 404. You just pass in the number itself or the variable itself, and that expression that you're passing in will be evaluated as whatever type you said the argument will have. Now the same rule applies to the return statement. The return statement can be any valid expression which evaluates as the return type which you declared. So for example, right over here I can return the results of calling do more stuff, and what that will do is it will call this function over here passing in this variable, and whatever is returned from that function will be used as the return value for this function. Again, notice how in the header, in the declaration and the definition of a function, only that's when I have to specify that I'm passing a integer, integer, but when I actually call a function, when I actually use that function, I don't have to specify the type. I just pass in the variable that I have right over there. And of course, the limits of our expression are very wide. As I said, you can pass inside of this function the results of calling a different function, using the results of calling the same function, whatever you'd like to do. And just don't lose track of your opening and closing parentheses, where they're supposed to wrap and what they're supposed to have inside of themselves. As you see right over here, for example, I have one opening parentheses over here, another over here, and another over here, but they don't all get closed because I forgot to add a third closing parentheses right over here. So don't lose track of your parentheses. And don't forget that the semicolon is only needed at the end of the line. So you don't have to have a semicolon right after calling each function. You just have to have one right at the end of the line. Don't forget that function definitions do not need a semicolon at the end of the function definition. You just leave it with a closing brace and that's enough. Only class declarations, like the soldier class right over here, must have a semicolon at the end of the class declaration. And back to our functions as expressions, calling other functions as expressions. That could get pretty confusing sometimes when you have a whole line of functions calling other functions and stuff like that. So make sure that whenever you do something like that, either you comment it well, you explain exactly what that line of code is doing, what functions are calling which functions, what are they doing and why, or you can just make things a lot clearer by dividing the tasks of calling the different functions and getting their results. Divide that into different lines of code, each one returning its value to a certain variable, and then passing that variable to the next evaluation, etc., etc. So that way things get a little clearer about what's going on, instead of having one line of a whole bunch of jumble of code.